Hey, good evening, everybody. It's Tim here. I am re-recording the show here at 9 p.m. because I understand there were some dropouts in the 8 p.m. show. So I figure it's only fair for me to do this so we convey a lot of the forecast information I try to bring across here an hour ago. So we'll see how this works, and if any of you are on and if you're here in the webcast, okay, let me know. And we'll redo this and see how it goes. I actually restarted the computer and brought up the audio board again, and I think we may have cleared up that problem. Okay, so 50s and 40s for Texas here. It's been kind of a very mild pattern. We had some cold weather about a week or two ago, and things are kind of flip-flop, and we're back to April conditions. So there you go. You can see 40s and 50s all through this area right here. Temperature's a little more seasonable up north. Got a lot of teens and 20s up in that region. The satellite picture, which we didn't really look at last hour, looks like this. And you can see that so-called Pineapple Express kind of shifting northeastward with a subtropical jet. So we're going to expect to find that subtropical jet maybe in this area here. We could also have maybe a coupled pattern like that. That's certainly possible because I can see a cutoff low way back here. The only way we can really know for sure is, of course, to take a look at the upper level charts. But what we can be sure of is that this whole area here is under the influence of some jet stream energy. And that's also helping to bring some mid-level moisture northeastward into Texas and New Mexico. The surface chart, let's bring that up. And so here it comes. Going to plot that up, and we can see Siberia right here, and they're pretty cold. See a lot of minus 40s and minus 30s up in that area. Not so cold in northern Canada. See a few little pockets of minus 20 here. But a lot of minus 9s, and there's 4 up in Fairbanks and 30 along the coast near Valdez, so that's a little bit on the mild side. And what we're looking at here, the tail end of a front in the southwestern U.S. And north of that, we can see some weak northerly winds in the Salt Lake City area, Winnemucca, and Elko. And to the south, some west-southwest flow moving through Arizona here. And temperatures are milder. They're up to around 60 there at Phoenix and 62 at Tucson. So that kind of supports the front being right in that area. In Texas, of course, things are a little bit more clear. There's the leading edge of that front right there. North of that, north winds, 40s and 50s. South of that, spring-like conditions with 70-degree temperatures and dew points in the mid-60s. And ahead of that, you can see some of this marginal VFR. These are like lower cloud layers, 1,000 to 2,000 feet off the ground, and that's due to the presence of a lot of moisture that's advecting northward, north of that front. North of that area, we can see downslope flow in Montana and North Dakota. Very strong westerly winds coming off the slopes of the Central Rockies right through that area. So let's go through and do our thickness and isobar analysis. This chart from NOAA is probably the most legible one to analyze online. So that's the reason I usually come and select this chart. And there it is right there. You can see that very strong banding of thickness lines right through here. So that's going to place the front from about Memphis through Dallas-Fort Worth and up to Las Vegas, kind of like that. And then the warm front, it's suggesting that it goes through Virginia, kind of like that, but we found from surface analysis about an hour ago that's actually located pretty far to the south in South Carolina and western North Carolina, so something like that. And then north of that, we're going to have a bit of an occluded front going through Ohio, western Ohio, right about there. and behind that, very strong cold air vection coming down the backside. In fact, looks like the core of the polar air way up to the north. Up there in the Northwest Territories, kind of centered there at Cambridge Bay. Maybe a little bit of a Arctic front moving southward, kind of like that. But you can see that there's a strong northerly gradient all the way down. So that's going to spell a lot of cool weather for the eastern U.S. as that makes its way southward. And one thing that I went over a little bit last hour was the experimental products from SPC. They've got this panel here called Mesoanalysis Graphics, and we were looking a little bit at that. And just to run through a few of these charts real quick. Observations, we have surface observations right here. That's pretty familiar, and you can tell that we've got this southerly wind kind of feeding up to these storms, but it's actually the moist air down at the south that is actually critical for helping to sustain them. See those 65 dew points down there? 61, 64. And we know that cold front is actually probably all the way down to Georgia. Maybe something like that. In fact, maybe it goes all the way up into northern Alabama like this. Okay. That's my cousin calling. Good timing there. Okay, so we're getting a little bit of overrunning over this, and there it goes like that. Give me a second. I'm going to mute this for his benefit. I'll be back in just a second. Okay, visible imagery showing nothing, radar base velocity. We saw that on that last frame like that. This VAD profiler data chart here, I was mentioning that last hour. We don't really know what that is and what's supposed to be on that chart. I would think that that's probably some upper level data, winds coming from the radars and the profiler data, but this is why I need to shut the phones off when I do the webcasts. Let's see. There we go. Moving on, VAD profiler data. That comes from the VAD VWP profiler information. You can plot that data because it's going to look like this. Let me show you. I don't know how many of you are familiar with the VAD VWP winds aloft, but the data is going to look kind of like this. I'll go to the Fort Worth radar site and bring that up for you. And at each radar site, this gives you kind of an idea of the winds from the surface on up to the top of the radar scan. Up here, this tops out at about 8,000 feet. That's about the top of the cloud material that will scatter back to the radar. And then this goes forward with time like that. Now, as you imagine, it should certainly be possible to plot these winds on a horizontal chart. And I think that's what SPC was trying to do here. But there are some other sources that let you do that, like at UCAR. Let's see if they still have that here. Nope, they took that off. So I don't think there's any way on the internet of using VWP data to plot horizontal charts. That's kind of sad because that's a good use of upper air data, especially in storm situations like across Texas and Oklahoma, where you just get a few balloon launches in the morning and no indication of the low-level jet strength during the day. But you could plot this on an 850 millibar chart during the day. Just take a sample from each of these radar sites and plot that, and that can help supplement your data coverage. And you'd have data from Fort Hood, from Fort Worth, from Abilene, San Antonio, Houston, all of that. And that can really give you a good idea as far as trends and location of the low-level jet. And then just running through a few more of these real quick. Let me get back to where I was. I have a couple more charts here. Surface pressure, temperature and wind, you're probably familiar with that. Then we have temperature, wind, and dew point. And the dew point is going to be these blue lines. You can see the tighter gradient right here, because the better moisture is sitting right down in this area here. And that's helping to feed these area of storms. You may wonder why these storms up here are kind of detached from the moisture. That's because the moisture is riding over the front. So we would find the moisture here. It may be about 2,000 or 3,000 feet off the ground, but that would be enough to feed the inflow into these showers. Okay, and just a couple more. There's moisture convergence, which you could use to do some storm forecasting. And that's these green values down here. That's going to be a combination of dew point and wind convergence, which is basically confluence of the winds and speed convergence. Now, for a while back in the 60s and 70s, this was often used to forecast severe weather initiation. Not so much anymore, because they're finding that it's better to use the actual raw data with as few terms as possible in each of these indices. So in other words, instead of stacking a bunch of different parameters together, you just use a couple of the most important ones. And that's what we do with stuff like CAPE and convective inhibition. Moisture convergence is stacking dew point with speed convergence and confluence, and sometimes it doesn't always work that way. Therefore, sometimes it's better just to use pure convergence. And we can certainly get that from here. It's in one of these fields here. Yeah, this divergence and vorticity field. That'll give you a more simplified picture of your divergence and convergence. And we can see on the bottom, convergence is going to be solid red, and divergence is dashed blue. So this here is a divergent area, not supportive of severe weather, or not supportive of initiation. Let me be more clear about that. And then red is going to be more supportive of initiation, storm initiation. You can see the wind flow coming together right here. So there's confluence of the winds right in this area, and that's supporting this little band of convergence. But once you have storms already, like you do right here, that's going to distort your field quite a bit. So we're probably picking up a little bit of the outflow right here, for example. But you're lucky if you're going to get even that. Sometimes your fields can be masked totally around your storms. And pretty much by this time, when you have precipitation going on, you're not going to be using these fields very much. This is mostly valuable for your pre-storm environment. Okay, this is when we should get back on track, so we don't run into overtime here. Let's go ahead and set up our forecast maps and look at the week ahead. Okay, that's the Canadian model, and here's our GFS. And I think we're ready to go with the forecast here. Okay, Jeff says he gets the VAD data from GR Level 3. Excellent. Wish Radar Scope had it. Yeah, I use Radar Scope all the time. I never realized it didn't have VAD wind data. But yeah, I'm going to be running some upgrades to digital atmosphere here when I get back into my programming routine in the next few weeks, and I plan to support some of that horizontal plotting of VAD VWP data. because that, like I said, that is very useful. So right now, here's that cold front coming south. Cold air advection blasting south. And by tomorrow, when we do the webcast then, we're going to be looking at this. Big push of cold air into the southeast U.S. Starting to develop a little bit of warm air advection on the backside. Then for Friday, coming up on the weekend, New Year's Eve weekend, it is going to be looking like this. And I may be going to San Antonio that day. A lot of traveling, and I actually feel pretty tired right now from all this travel. Warm air advection setting in just ahead of this Alberta Clipper coming south. And then for New Year's Day, or New Year's Eve. Yeah, Saturday, New Year's Eve. Here we go. A push of cold air comes south in Oklahoma and North Texas. A little bit of upslope snow in the Dalhart-Clayton area. But you see this large area of warm, moist air developing in the southern U.S. Subtly gradient right there. You'll see that expand as that front stalls. So by Sunday, New Year's Day, we're looking at a very large area of warm air advection right here. So it looks like more mild weather for the southeast U.S. and Texas. But we have another Alberta Clipper working southward. So here it comes by the 2nd, looking like this. By the 3rd, continuing to push southward and build. So it's got a lot of upper air support. By the 4th, coming through Texas, that's going to be a big change. Large area of polar high coming southward, lots of cold air advection. And coming up on the 6th, this is where things get a little bit weird out on the West Coast. I'm going to show you the Canadian model in just a bit. Here in Texas, we're under high pressure, but we're developing warm air advection pattern right here. You can see a lot of showers and a little bit of upslope flow here. So this is going to be kind of a cloudy period here Friday next week. But where things get different, let me show you the Canadian model. We'll run this up to the 5th and the 6th. And you can see what happens is the Canadian model wants to bring in the storm system into the Los Angeles area, and there it is right there. Heavy rains in the Los Angeles, Ontario area, in the mountains near San Bernardino and north of Pasadena, north of Burbank, all that. San Gabriel Mountains, I think that is. A lot of heavy snow, and also snow in the Mojave Desert up to Las Vegas, Tonopah, China Lake. Looks to be a pretty potent system there. And that'll have a big effect on Texas, Oklahoma, and Kansas if that pans out, because coming in the backside, very deep, cold polar air coming southward across the mountains. When we see these thickness lines dipping south like that across the Great Basin area, that's a good tip-off that there's a very deep cold air coming south. And as that frontal system moves eastward, it's going to be kind of a cold period here coming up for the 8th and 9th and 10th, if the Canadian model is correct. GFS, though, going with a different pattern here. 8th and 9th looking like this, just kind of a very warm pattern in advance of this next system. And then that finally comes south around the 12th. So a lot of differences in the models after the first week of January. And at the very end, GFS here going for a big winter storm across Oklahoma and Kansas. And a big 1060 millibar high over Montana. That'll definitely develop a good cold push going all the way to the Gulf. Basically, whenever you see a 1060 high, that's always going to be able to reach the Gulf. That's kind of a rule of thumb right there. So, 21 minutes. There's our redo of the 8 p.m. webcast. I hope those of you who had problems with the 8 p.m. one, hope this works better for you. Anyway, that's going to be it for me, and I appreciate you watching, and we should be back up to speed at the usual time, 8 p.m. tomorrow. And I hope we see you then. Thanks for watching.